Hello everyone. Through this video we are going to discuss a very simple but important topic, that is concept of factorial. This concept of factorial is extensively used in these two important parts of mathematics, that is permutation and combination and binomial theorem. After this we shall come to the mathematical representation of factorial. Actually, in what way factorial is represented in mathematical context. So this is the mathematical representation. The factorial of any natural number n is denoted by n factorial. This is one way of representing factorial, and this is another way, or either this one or this one we can use here. So for example, any natural number, always we must have to consider one thing, that factorial is applicable only in case of natural numbers. 0 factorial will be having some specific value that we shall be discussing later on. Negative numbers are not applicable in case of factorial. So here in this case, the factorial notation of any natural number n is n factorial. This is one way of writing, and the other way is this one. So any one of these two representations we can consider while representing factorial notation with any natural number. After that, let's come to the part definition. How can factorial be defined? How to define factorial n? Now, the notation factorial n represents the product of first n natural numbers, that is, n factorial is equal to n into n minus 1. Look at one thing. First number, actually where we are putting this factorial notation, in the expression, in the main expression part, the values goes on decreasing, but there is into notation in between. That means, for example, say I am taking one example here. For example, factorial 7. Factorial 7 is equal to, if I follow this rule, then 7 factorial can be written in what way? 7 factorial, that means n is getting replaced by 7. So on the right hand side, how we are going to write? In place of n, we shall write 7. Okay. Then after, the next factor that will come here will be 7 minus 1. 7 minus 1. Okay. Then the next term is 7 minus 2. Where there is n, there in that place I am going to put 7 here in this example. Then after, again in this place I can put 7 minus 3. In this case, value of n was quite unknown to us, yes or no? But in our case, in case of this example, value of n we know, and that is 7. So we can continue up to the last digit what we are going to get. So let us check here. The next number should come as what? 7 minus 4. Then again the next number will come as 7 minus 5. Then after, the next number will come as 7 minus 6. Actually, we should always keep in our mind one thing, that the last three numbers, in case of splitting of any factorial notation, we should get as 3, 2, 1 wherever necessary. Last term should come as 1. So here when we do this subtraction, 7 minus 6, the result will come as 1. Let us check that in the next step. 7 into, from this part I am going to get 6 into, then from this part I shall be getting 5, then 7 minus 3, the result will come as 4, then from this part the result will come as 3, then after, from the later part, again the result will come as 2, and in the last term we shall be getting the result as 1. So this is the complete splitting of factorial 7. Similarly, taking another example, similarly what we shall get, Say I'm taking 5 factorial. In this case, what will happen? Like the previous one only, 5 into 5 minus 1, this is the first subtraction. Then after 5 minus 2, like this it will go on decreasing unless and until we get the value 1. 5 minus 3, then 5 minus 4. So this is the term where I can get the value 1. So after this, 5 into 4 into 3 into 2 into 1. So this is the complete splitting of factorial 5. Now we shall consider a specific case. But there is a but here. Let us consider the case. Let us consider the case five factorial by 3 factorial. Now in this case, when I break 5 factorial like this, I should get what? First term will come as 5, then the second term will come as 4, and the third term I am going to keep like this, 3 factorial. And the denominator is also 3 factorial. I am not going to break the later part of the numerator. After 3 factorial, I am not going to split anything. Why so? There is a reason, because for doing cancellation, in the upper part and the lower part, I mean in the numerator and denominator part, our requirement is what? 3 factorial. No doubt we can split like 5 into 4 into 3 into 2 into 1. And in denominator also 3 into 2 into 1. In this way we can do the splitting, but this is the standard way of writing 3 factorial. Both in numerator and denominator we are getting the same result. If I confine myself with this 3 factorial part, then also there is no mistake, because ultimately 3 factorial gives us the result of multiplication of these 3 parts only. Yes or no? 3 into 2 into 1. Therefore, the numerator part, actually this factorial notation can be used according to the requirement. So in this case, our requirement in the numerator is 3 factorial. Anyhow, if we get 3 factorial, we can perform cancellation with the denominator. So the result will come as 20. So this is how we have to write down. After this is all about actually factorial notation. The necessary informations already I provided. Along with this, I want to add something more. Clearly, actually we already got n factorial is equal to n into n minus 1, then n minus 2, then n minus 3, continuation up to 3 into 2 into 1. Where the most important part is where n is a natural number. N is a natural number. Now, clearly for natural number n, clearly for the natural number n, what do we get? We get what? N factorial can be written as n into n minus 1 factorial. As we keep like this 5 factorial, I can keep it as 5 into 4 factorial also. Yes or no? So in the same way I can write like this. Similarly, this can further be written as n into n minus 1 into n minus 2 factorial. But there is a requirement, provided n greater than equal to 2. This is the requirement here, because n must be greater than equal to 2. Otherwise, the result will become a negative number. Again, I can write like this. Again, I can write like this. N into n minus 1 into n minus 2 into n minus 3 factorial. So in this case, provided n is greater than or equal to 3. So this can be, factorial notation can be used in these ways as and when necessary. So that's all about the importance of factorial and the concept of factorial. So let's discuss some special questions now. So here goes the first question on factorial. Actually, this is a question which involves the concept of factorial. So in the solution part, what I shall be writing, given, actually this is the thing given to us, yes or no, this is the expression which is given to us. Given 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial. On both the sides, if I notice, I shall get what? 6 factorial is the lowest term found among these denominators, yes or no? So I'm going to use a technique here. Let us check what is that. In this denominator, this first fraction I'm going to keep as it is. In the second part, what I am doing, this can be splitted into the form 7 into 6 factorial. Yes or no? These things we had just discussed few minutes back. Then on the right hand side, the denominator can be written in what way? 8 into 7 into 6 factorial. Now we can observe one thing, that in all these three terms, both in LHS and RHS, we find this term as common. Yes or no? 6 factorial as common. So that is why I am going to take common on the left hand side. What term I can take common on both the sides? Of course, 6 factorial. I am going to take common 1 by 6 factorial on both the sides. What will be left within the bracket? It is 1 plus 1 by 7 is left here. That is equal to x by, again I can put here 8 into 7, and I am going to keep 1 by 6 factorial common. So on both sides, these two terms we can cancel out, yes or no? After that, what can we do? On this left hand side, I can take common, I can take 7 as the LCM. So in the numerator part, I am going to get 7 plus 1, that is equal to x by 8 into 7. So in the next step again, I am going to get what? This will be 8 by 7 is equal to x by 8 into 7. So 7 on both sides got cancelled. Then performing cross multiplication, I am going to get here 64. 8 8 just 64, and this is the answer for this question. We had to find out value of x, and this is the required value. Now let's come to the second question now. This question is also of same kind. Let us see what is it. So here goes question number 2. What is said here? If 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial, then we have to calculate value of x. Let us check. Given 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial. So like the previous question, we can notice one thing, that 8 factorial is the lowest denominator. Yes or no? So we are going to proceed like the previous sum only. I am going to split the second term in this way, 9 into 8 factorial. Then after I shall be getting x by 10 into 9 into again 8 factorial. Now on both the sides I can take common 1 by 8 factorial. Within the bracket, in its place I shall be writing 1, then after what is left, 1 by 9. That is equal to 1 by 8 factorial into x by 10 into 9. Okay. Then after, let us check the next step. Of course, we can do cancellation on both sides. 1 by 8 factorial, 1 by 8 factorial gets cancelled. And then after, while taking LCM on the left side, I'm getting 9. Then 9 plus 1, that is equal to x by 10 into 9. Yes or no? 9 on both sides got cancelled, and ultimately I am getting the result 10 into 10 is equal to x. So the result of x comes as 100. So this is the answer for this question. Let's come to the next question now. So here goes another question. This is again important, which involves factorial concept. So we have to prove that LHS equals to RHS. So of course we are going to start with LHS. So in this case, I'm going to keep this first term as it is, then the second term as 1 by 10 factorial. Then LHS directly I'm writing here as it is given in the question. Then after, in the next step, I'm going to split the terms in this way. 9 factorial is the lowest term. The same thing I'm going to repeat here also. I'm going to reduce each factorial to this lowest term, 9 factorial, like this. 10 into 9 plus 1 by 11 into 10 into 9 factorial. So after this, if we find out the LCM, which one should become the LCM? This is the greatest one, yes or no, biggest of all. Therefore, we shall be writing here 11 into 10 into 9 factorial. And the result will come as 9 factorial is already there. What is left here? 11 into 10. So this is to be multiplied with this one to get the result 110 plus again 10 and 9 factorial. These two terms we find in the denominator of the second term. What is not present here? Out of this, only 11. So 11 will get multiplied with 1 to give us the result 11 plus this denominator and this one are exactly same. That is why here the result will be 1. Now 110 plus 11 plus 1. The result comes as what? 122. Yes or no? And in the denominator part, if we join these three terms, ultimately we are going to get back the result what? This gives us back this result. Yes or no? 11 factorial. 11 factorial. So this is the required right hand side. Yes or no? This is the required result. This is what we wanted. So this is equal to the right hand side. Hence proved. After that, coming to the next question. Question number 4. What is given here? If n plus 2 factorial is equal to 60 into n minus 1 factorial, then we have to find out n. So this is a bit twisted. What is given here that we are going to write first? N plus 2 factorial is equal to 60 into 60 is not associated with this factorial part, okay? That is why this third bracket is given. Let's close it. So after this first and foremost thing that we have to do here is what? Factorial notation on both the sides will have to be removed. In what way? See, n plus 2 is bigger or n minus 1 is bigger. Which one is bigger? Of course, n minus 1 is smaller than n minus 2. Yes or no? Sorry, n plus 2. So in this case, n plus 2 is bigger and n minus 1 is smaller. So I'm going to split this left hand side in such a way that I can get this n minus 1 factorial form anyhow, so that it gets cancelled with that n minus 1 factorial present on the right hand side. So what I'm going to do? First term, while applying factorial splitting, first term that will come here will be n plus 2. The second term that comes here will be what? N plus 2 minus 1. Yes or no? Then the third term that will come here will be n plus 2 minus 2. It goes on decreasing. Then after n plus 2 minus 3. So this is the position where we can get the required result, means n minus 1, because n plus 2 minus 3 will give us a result n minus 1. Yes or no? That is equal to 60 within bracket n minus 1 factorial. So coming to this side, n plus 2, the next term will be n plus 1, the third term will be n of course, then after the next term is n minus 1 factorial is equal to 60 into n minus 1 factorial. So ultimately these two terms gets cancelled. After that n plus 2, then after n plus 1, then n is equal to 60. Now in this step we have to apply a specific technique. That is what? Let us check. The technique will be what? I'm going to do factorization of 60 first. Let's factorize. By 2 it is divisible, so it will be 30. Then after again by 2 it will be divisible. The result comes as 15. Then after I'm going to put here 3. 3 5 ja 15. Now these two quantities will give us the result 4 on multiplication. So we are getting 3 consecutive numbers here. First one is 5, second one is 4, third one is 3. And on the on the left hand side we again can get 3 consecutive numbers. First one, smallest one is n, next one is n plus 1, then after that I'm getting n plus 2. So in the next step what do I get? N plus 2, then n plus 1. I'm keeping as it is. These terms I'm keeping as it is so that the splitting can be done properly on the right hand side also. No need to do partwise multiplication on the left hand side. So 60 can be written in what way? The biggest term I'm writing first because this is the biggest one on this side, followed by 4, this is the middle one, then after 3. Now for doing comparison on both the sides, for getting value of n, actually I'm going to compare both the sides to get value of n. 5 can be written in what way? If I want to write it in this form, it can be written as 3 plus 2. Yes or no? Then second term can be written as 3 plus 1. Am I right? Then after the third term will be as it is. Now if we compare both sides, comparing both sides, we can get what? N comes as 3. And this is the required answer. Thank you.